All right, welcome. Today we're going to get into a really meaty GCSE chemistry topic, electrolysis. We're going to take a full 16-mark exam question and just pull it apart piece by piece so you can see exactly how to bag every single mark.
So, here's the plan. We're going to walk through question 07 section by section using the official AQA mark scheme as our roadmap. By the end of this, you'll know exactly what the examiners are looking for, no guesswork involved.
Okay, so the question kicks off with a big industrial process, getting aluminium from aluminium oxide. Let's get into the first part.
Right, first up, a classic 2-mark explain question. So they don't use pure aluminium oxide, they mix it with something called cryolite. And the big question is, why bother? Here's the deal for these 2 marks. It's a cause and effect chain. First point, you have to say that the mixture has a lower melting point. But you don't get the second mark unless you explain why that's a good thing. And that's because a lower melting point means less energy is needed. You need both parts of that story for the full 2 marks.
Okay, moving on to question 7.2. This one's a 1-mark multiple choice, and it's all about what's going down at that negative electrode, the cathode.
So we've got 4 options. Now, the key thing to remember with electrolysis is that we're dealing with ions. So right away, we can ignore the options about aluminium atoms. And at the negative electrode, positive ions are attracted, and they gain electrons. That process is called reduction.
So, the correct answer is aluminium ions gain electrons. It's all about precision. You get that single mark for being super specific. It's the ions that are gaining the electrons. A really crucial detail.
All right, next up, we've got to complete a balanced half equation for 2 marks. This is where you really have to know your stuff about balancing and ion charges.
So, this is what the exam paper gives you. Just an arrow and the oxygen. Your job is to fill in the blanks. What are we starting with, and what else gets made?
And here's the completed answer. You get 1 mark just for knowing that we start with the oxide ion, O2-. The second mark comes from getting the balancing perfect. 2 oxide ions make 1 oxygen molecule, and in the process, they release 4 electrons.
This is a fantastic 3-mark question that really tests if you understand the whole process. Why do those positive electrodes, the anodes, keep having to be replaced? It's a huge industrial cost, so it's an important detail.
Okay, to get all 3 marks here, you have to connect the dots in a logical chain. Step 1, state what the electrode is made of. It's carbon or graphite. Step 2, explain that this carbon electrode actually reacts with the oxygen that's being produced right there. And step 3, what does that reaction make? Carbon dioxide. So the electrode is literally burning away, which is why it needs replacing.
Okay, deep breath. We're switching gears now, moving away from the theory and into the first of the 2 big calculations in this question.
So this is it, a 4-mark calculation. These are all about reacting masses, or what we call stoichiometry. The good news is they give you everything you need: the balanced equation, a starting mass, and the relative atomic masses. The absolute key here is to show every single step of your working.
Let's walk through it. First, we have to find the moles of aluminum oxide we're starting with. Remember to convert kilograms to grams first. Second, we use the big numbers in the equation, the molar ratio. It tells us that for every 2 moles of aluminum oxide, we make 3 moles of oxygen, so we use that ratio. Third, we turn our moles of oxygen back into a mass. And finally, the question gave us kilograms, so we should give our answer in kilograms. Each of those steps gets you a mark.
And there we go. After all that, our final answer is 941 kilograms. Following that clear 4-step process is exactly how you secure all 4 marks. No shortcuts. Okay, we are leaving aluminum behind for a bit. This next part of the question switches up the electrolyte to test a really important chemical rule. Here we go, another 2-mark explain question. This is a great one. If you want to make sodium metal, why can't you just take some salt water, sodium chloride solution, and run electricity through it?
The entire answer hinges on the reactivity series. To get the marks, first you have to state that you'd get hydrogen gas instead of sodium. That's your first point. Then you have to explain why. It's because sodium is more reactive than hydrogen. In a solution, you've also got hydrogen ions from the water, and it's always the less reactive positive ion that gets discharged at the cathode.
We are on the home stretch now. The very last part of question 07 is another calculation, but this time it involves a gas.
Okay, a 2-mark gas volume calculation to finish things off. They've given us the mass of chlorine, is formula mass and that golden piece of information that 1 mole of any gas at room temperature and pressure takes up 24 decimeters cubed.
This is a lovely, clean two-step job. First, we find the number of moles of chlorine gas. Just convert the mass to grams, then divide by the MR of 71. For the second step, we take the moles we just calculated and multiply by that magic number, 24, to get the final volume.
And that's our final answer, 50,700 decimeters cubed. A nice, satisfying calculation to wrap up the entire question.
And there you have it. That is every single part of that 16-mark question totally deconstructed. We've seen exactly how to get every mark. But the real question to ask yourself now is, can you explain the fundamental chemistry, the why, behind each of those answers? Because that's when you know you've really mastered it.